So students, now we are considering that insurance case that we discussed during the lecture. Okay? So now this is an exercise. So if it was not clear during the lecture, now it will be clear to you. Okay? Now we are considering a person who is going to purchase an insurance or not. So now let's suppose we have a person who has money of, let's suppose, 10 sums. Okay? So let's suppose I have 10 sums, and at the same time I have a car. And I have a car. And the price of my car is 40 sums. 40 sums. I have 10 sums cash, and I have a car which costs, so the price is 40 sums. What is the total wealth that I have? 50, right? So now I have 50 sums of total wealth. This is my wealth. And students, now, if I want to drive a car, it seems that I have three options, choices to make. One is I can buy full insurance. The second one is I can buy one specific type of insurance, insurance against theft. And the third one is make a decision not to buy any insurance. If I'm going to purchase full insurance, how much do I have to pay? 5 sums. If I don't want to buy full insurance, but instead if I'm going to buy insurance against theft, then I have to pay 3 sums. And another option, third option, if I decide not to buy anything, not to buy insurance, no insurance, then it means I don't have to pay anything. I don't have to pay anything. But there is one problem with buying no insurance, because driving without insurance is illegal. If police stops me, what is the fine? 15 sums, okay? So if police stops, then fine is 15 sums, which is quite significant amount of money, okay? So now we have these three cases. Now let's start calculating things. All right. Considering the given likelihood of different incidents to happen, find the final wealth from possible consequences of him buying insurance. So now what you have to understand here, we are considering full insurance, insurance against theft, and no insurance cases, all right? And now we are considering 4 possible outcomes. If I am going to buy a car, there is one risk that car can be stolen. And let's suppose in Uzbekistan we have collected the data, and we have done all the research, analyzed, and it shows that many years of data shows that in Uzbekistan, let's suppose, the probability of anyone's car being stolen is 6%. Okay, there is such a risk. Car can be stolen. So data says this one. And let's suppose that, again, those statistics are telling us that the likelihood of being in an accident is 4%. If you buy a car, because there is a risk of being in an accident. And another thing is police. So the likelihood of anyone, of any driver stopping by the police is 10%. Okay, this is another one. And here, there is 80% likelihood that nothing is going to happen. Your car will not be stolen, so you will not be in an accident, or police will not stop you. So that one is 80%, okay? So now we are going to consider, if we are going to purchase full insurance, so which means that now I am purchasing. So this is total wealth that I have, including 40 sums of my car's price, okay? And here, my cash. Money that I have, cash. So now I am purchasing full insurance. How much should I pay? 5 sums. So what will be my total wealth then? 45, right? If I'm going to buy it, then I will have 45 sums. 45 sums. Okay. Look, now we are going to write these things here. First, so here we are considering car if car is stolen. Okay? This is first case. Second one, if the car is in an accident. Okay? Third case, stopped by a police. And the last one is nothing is going to happen. Nothing is going to happen. And what is given for us? The probability of being stolen is 6%. Probability of being in an accident is 4%. Stopped by a police, 10%. And nothing is going to happen is 80%. So we have these probabilities. These are probabilities. Okay? And let's suppose now I decided to purchase full insurance. Full insurance. Which means that I paid 5 sums and purchased full insurance. Now, I purchased my car, I purchased this insurance, and I ended up that my car was stolen. Okay? Now, I lost my car, it's stolen. How much wealth I will have then? 45. Why? So the insurance company, because it covers those cases, insurance company will recover, will buy me a new car, or will pay that money back. Okay? What if I am going to crash my car? I got in an accident. So it will be still 45. Why? Because insurance will cover it. I was stopped by police. What will happen? How much wealth I am going to have? 45. 45. If police stops me, what police officer is going to ask me? Show me the document, whether you have insurance or not. Here, full insurance. Oh, good. You can go. That's the case. No problem. 45. So if nothing is going to happen, 45. Because I already paid. Okay? Now I already paid. So this is in the case of full insurance. Good.
I have a question. 45 means here 40 is the price of the car and 5 is the...
Yes, what I have left in my pocket. Okay? Good. Next one is insurance against theft. If I purchase insurance against theft. So now, let's suppose now for insurance against theft, I paid 3 sums. How much I have left? 47. And it happened that my car was stolen.
47.
I will have 47. Because it is against theft, insurance will cover it. Okay? Insurance will cover it. 47. If it's going to be accident case, it will be 7. 7. Why? Because that insurance against theft covers only for theft. It does not cover accident. If I got in an accident, I lost my car. This is it. What I have left, that's 7. So this is 40 sums at the car price and plus $7 cash that I have. I have left this one. I lost this one. Good. What if I am stopped by a police? 47. Doesn't matter. It's totally up to me. Which insurance? Do you have insurance? Yes. Okay. But this insurance is a little risky. Okay, but I have the document. No problem. If nothing is going to happen? 47.
But the insurance, because it's not like for only police, yes?
Insurance doesn't matter. It's totally up to you. The more you pay, more, services you will get. So here, I'm paying less, so I have less service. I'm paying more, I have more service. Okay? That's the case. Next one, third one. No insurance. No insurance. So now, if my car is stolen, gone. So I actually had 10 sums, right? And plus 40 sums of car price. Now car is gone. So then I will end up with 10 sums. If I get in an accident, again, 10. If I'm stopped by a police, it will be 35 because there is a penalty of 15 sums. So now it will be 35. If nothing is going to happen, it will be 50. Okay, it will be 50. So now we have written everything, okay? So student, in your final exam, you may have questions like this one. Out of this given information, you have to fill these tables, okay? Then after, you can make calculations. Once they have right tables, then you can make calculations, all right? Good. So now we are asked, write each prospect with listed probabilities and monetary payoffs. These are probabilities, and these are monetary payoffs. Okay, let us write those prospects. So now we have three prospects. Prospect for full insurance, prospect for insurance against theft, and prospect for no insurance. Okay? Good. So let's write first one. Let's write first one. So prospect, okay? Prospect for full insurance. Full insurance. Prospect for full insurance. I think this one is better. So now if I'm going to write prospect for full insurance, it's going to be, what is the probability of monetary payoff of 45 sums? 1. In any case, it is 45. So which means there is 100% probability I will have 45 sums. So there is 100% probability that I will have 45 sums. Okay? I think now it's clear. Second one, I'm deciding to purchase that second prospect, insurance against theft. Insurance against theft. What is the probability of monetary payoff of 47 sums? 47. 6, 10, 8. So total, it's going to be 90, 96, right? 90, 96. 47, 47, so 47. In 3 cases, it's 47. Okay? So now there is 96% probability that my monetary payoff is going to be 47 sums. Okay? This is the case. And we have another case where, what's the percentage of what the probability of having 7 sums? 4. And we have another case where there is 4% probability that the payoff is going to be 7 sums. This is prospect for insurance against theft. And now we have another prospect for no insurance. Okay, no insurance. What's the likelihood of monetary payoff of 10? 10, right. Now there is 10% probability of having 10. And what about 35%? 10%. 10% of having 35. And this one, 80. So we have 80% of monetary payoff of 50. Okay, good. So now we have written these prospects, okay, good. You must be very, very clearly aware of how to write these prospects. You should know it, okay? It's important because we will be doing it many, many times. Many, many times. Good. So now we are done. Next one. Now, assume utility function is given as the following, okay, utility function, which translates money into utility. So now we are saying that more money we have, more happy we are. Okay, so now it translates. Find expected utility for each prospect considering people being risk neutral, risk averse, and risk loving. So according to our lecture students, if our utility function is linear, what type of people does it describe? Risk neutral people, right? If it is in the square root, so concave, risk averse. If it's convex, risk loving. So now we are considering 3 cases, okay? 3 cases. And we will find, in the case expected utility, in the case of full insurance, insurance against theft, and no insurance. We will do it now together, okay? We will do calculations. All right. So now, okay, let me do it like this. So, all right. First is the case is full insurance case, okay? Full insurance case. Second one, we are considering insurance against theft. And the last one, we are considering no insurance case, okay? No insurance case. And we will see what choice people will make. And now, so this, we have to calculate expected utilities for all. First one is linear. Our utility function is linear. So it's linear. Okay, let's calculate. If you are going to find expected utility from full insurance, because it's linear, so now we have to multiply that 100% probability to 45, yes? Which is equal to 45. So expected utility is 45. Good. We are done with it. Next one. So second one. If we are going to purchase insurance against theft, now we are saying that there is, so yes, we will add because we are using that utility function which is given there, right? Let me write down for clarification. Our utility function is the sum of all probabilities and our function I. Okay? So now in the second case, our utility function for full insurance is equal to, we are saying there is 96% probability of 47, right? Plus second option, so here 4% probability of 7. So if I have these calculations here instead, so it's going to be 45.4, right? 45.4, done. And let's do these calculations for last prospect. Insurance again, no insurance case, so utility functions for no insurance is now equal to 10% probability of having 10 sums plus we have another 10% probability of 35 and plus we have 80% probability of 50. Is it right? It's equal to what? 44.5. 44.5. Okay, good. So now if we look at the results, students, from which prospect we are expecting the highest utility? It is against theft. So now, according to because we are expectation is the highest instead of against theft, so risk neutral people will decide to purchase which type, so this not this one or not no insurance, but they would purchase insurance against theft because it's the largest.
But the risk power is also going to purchase.
Doesn't matter. It is the nature of a person. Okay? So now, therefore, we have different utility functions. What about in the case if people are risk averse, who do not like risk? Okay? So we will see the situation will be different. So now we are considering utility function in the case of person is risk averse. Okay? Good. So now let's calculate this one. If it's going to be the case, our utility function for full insurance. So now there is 100% probability that our payoff is going to be 10 times 10 in the square root. Oh, sorry, 45. 45. Because the payoff is 45. So now it's equal to 67.08. Okay, if you do calculations, you will get this number.
I don't understand this part. Like why we are multiplying 10 by 45 in square root?
Because this is the payoff, x. Here. This is the payoff, okay? So this x represents here. These all represent x, these payoffs, okay? Good. Next one. Utility. So now insurance against theft for risk-averse people. Now we said there is 96% probability that payoff is going to be 47, where 10 times 47 in the square root plus, okay? So then, 96, sorry, it's 96%, right? So thank you. So 96%, and we have 4% probability, right? 4% probability of 10 times in the square root of 7 plus, and the last one we have 80% probability of 10 times in the square root. Oh, sorry, we don't have it. We don't have this case, right? We don't have this case, only two cases. So this is equal to, if you calculate, 66.87. 66.87. So now we have these two outcomes, right? So here, therefore, we have included these two. Done. These two. And the last one in the no insurance case, so utility of no insurance is equal to, now we have 10% probability of 10 times in the square root of 10 plus, we have another 10% probability of having that payoff of 35, right? And plus, we have 80% probability of 10 times in the square root of 50. So this is the case. So now if you do the calculations with your calculators, it is 65.65. You will get the number of 65.65. So now we are considering people who do not like risk. So from which prospect we are expecting the highest utility? Full insurance. So does it make sense? A person who do not like risk, that person really purchases full insurance which covers all the risk. Okay, all the risk. So this is full insurance. That's the case. All right. So now, next one. What if a person is risk-loving? Risk-loving. Our utility function is convex, okay, convex, x squared over 20. Now we will calculate this one. Our utility function for full insurance is equal to, there is 100% probability of our payoff is going to be 45 squared over 20. Okay? And if you calculate this one, this will be equal to 101.25. 101.25. Second one, if we are going to consider that insurance against theft, here, now we said there is 96% probability, right, of payoff of 47 squared over 20 plus, and we have 4% probability of 7 sums of payoff, which is squared over 20. If you calculate this one, you will get the number of 106.13. 106.13. Okay? Good. And the last one, no insurance case. So now, no insurance case, if we do the calculation, so it will be equal to, so there is 10% probability of 10 squared over 20, right? Plus, there is another 10% probability, of 35, right? 35. 35 square over 10 over 20 plus, and we have 80% probability of 50 square over 20. If you do the calculations, it will give you 106.63. 106.63. So a person, from which one a person expects the highest utility? No insurance. Does it make sense? Yes, right? Those risk-loving people, they will be risking for this maximum. All right? I will take a risk. There is still 80% probability my car will not be stolen, no accident, and no police. I will risk, and I will have the highest payoff. Okay? So now, this is the case. Risk-neutral people will choose something because they are neutral, something in between. Risk-loving people, risk-averse people will choose the prospect with the no risk, okay? And risk-loving people, they will choose no insurance case, where the risk is the highest. Okay, good. We are done with it. We are done with it. Next. So now, students, so this is the utility function, right? This is the utility function that we are considering here. Now we are saying that now it represents value function. Value function. If we say value function, these are the numbers. It doesn't mean that one utility. So here, 67.08, it does not represent utility. Okay, it is value. So now we are considering value function here. And now, find the expected values and risk of different choices. I'm going to erase this part, students, okay? I'm going to erase, or I will erase the upper part, okay? Which you have. Upper part, I will erase this part. Okay. So students, now we are considering full insurance and these three types of, again, the prospects. Full insurance, insurance against theft. Let me make it a little down. Insurance against theft. And the last one, no insurance, okay? No insurance case. And I say you now remember it, okay? All right. So now, first thing that we have to calculate is expected value. Expected value. Expected value. Expected value. Expected value and expected utility calculating is the same number. But the thing is, it does not transform it into utility. Expected value of full insurance is equal to, oh, by the way, we are considering people who are risk neutral, okay? Our utility function here is X. If you have this question in the final exam, you will be given whether the person is the risk neutral or risk averse or risk loving. It will be given to you, okay? So now we are considering the person is risk neutral, then expected value will be equal to?
45.
It's going to be equal to 45.4. Is it the case? If it's full insurance. Is it?
No,
45. 45. If it is insurance against theft, 45.4.
Yeah.
So this is the same. So now what we are representing is now it is a value function. This is it. 45.4. 45 44.4. And the last one, no insurance, 44.5. Okay? This is the case. We have done it. And now, minimum possible. Minimum possible. If we are purchasing, full insurance, what is minimum possible of outcomes?
44.
Minimum possible. 45. Is there something less than 45? In full insurance. Full insurance. 100% probability of 45. Yes? So this is 45. Insurance against theft, what is minimum possible? 7. No insurance, minimum possible? 10. Yes, okay. And now, maximum possible. Maximum? 45. In the case of insurance against theft? 47. No insurance is 50. Good. All right. And the last column. Probability wells below expected value. What is the probability in the case of full insurance that our value is going to be less than expected value? Is there any probability that value is going to be less than 45? Full insurance? No. 100% probability it will be 45. There isn't any case. So probability is 0. And what is the probability, of the cases where our value is going to be less than 45.4? There is only one case, right? Only one case, which is going to be 7. In any other case, it will be 47. So now we have 4% probability of our value is going to be less than expected value. And the last one, in the case of no insurance,
No, 20%.
it's going to be 20%. Right, 20%. Why? So now in this case we have this 10%, 6% of stealing or car being stolen, 4% of car being in an accident, and stopped by a police. In all cases it's less than 44.5. So now in the case of no insurance, I said we have 6%, right? Probability of car being stolen. If it's stolen, we will end up with 10 sums, right? If accident, 4%, we will end up with 10 sums. Is it less than our expected utility? Yes. Is it less than expected utility? Yes. And we have another 10% probability where it will be 35. This one is also less than this one. So now there is 20% probability that our payoff is going to be less than our expectation. Okay, so therefore it's 20. It's 20. All right? Done. So based on the result found with linear expected utility and expected value functions, which prospect would risk-averse and risk-loving people are likely to choose? So we have answered the question, right? Risk-loving people will choose no insurance. Risk-averse people will choose full insurance. Done. We are done with exercise 1. We are done with exercise 1. So now I am going to play a video, students. Now we have to watch it carefully. Watch it carefully. It's about LA's paradox, which, the second exercise is going to be based on LA's paradox, okay? Which is not so simple. I hope that
Okay.
I think it's too loud. Okay.
Okay, I have a hypothetical situation for you and you need to make a choice. So listen carefully. You've just visited the doctor and she told you you're going to die unless you get treated immediately. There are two treatments. The blue pill would give you a 100% chance of living another 12 years before dying, and the red pill would give you an 89% chance of living another 12 years, a 10% chance of living another 18 years, and a 1% chance of sudden death. So, which do you choose? Now, remember your answer and imagine a slightly different scenario. Your regular doctor is out that day, so you go to a slightly dodgier one next door who offers you two treatments. The green pill gives you an 11% chance of living 12 years and an 89% chance of sudden death. And the yellow pill gives you a 10% chance of living a full 18 years before dying with a 90% chance of sudden death. So, which one of these do you choose? So, what did you base your decisions on? Behavioral economists think we make decisions based on something called expected utility. It's how much we expect that something will satisfy our wants and needs. If you like chocolate ice cream more than vanilla, you'll feel more satisfied if you choose chocolate. So for you, chocolate ice cream has more expected utility. Studies show that in the previous question, most people choose the blue pill in the first scenario, giving them a guarantee of living another 12 years, and the yellow pill in the second scenario, giving them a 10% chance of living another 18 years and a 90% chance of death. But what if instead we write out the options like this? Now the options have something in common. In the first scenario, in both cases, you have an 89% chance of living 12 years. So if we remove that, your decision shouldn't change, right? Kind of like how removing a cherry from both ice creams won't change your favorite flavor. In the second scenario, both options have an 89% chance of death in common, so we should just be able to cancel those out too without changing your decision. Hold on, now both scenarios are exactly the same. But studies showed that most people chose the blue pill in the first scenario and the yellow pill in the second one, which doesn't make sense. Both the blue and the green pills give you a higher chance of living over the chance of a longer life. And the red and yellow pills give you a chance of a longer life, but with a drawback of a lower chance of living. So for people who choose the blue and yellow pills, what do they want? A higher chance of living or a longer life? This is called the Allais paradox. It was first outlined by Maurice Allais, a Nobel Prize-winning economist in a 1953 article. The paradox undermines the theory of expected utility because it shows that we don't always make decisions that align with our wants and needs. We tend to make decisions based...
All right, students. Now, okay, where is that? Just a second.
You base your... What did you base living a full 18 years before? Expect that something so that in the previous...
Okay. So now we have this data, right? So if it was not so clear, I'll try to make it clear to all of you. What is LA paradox? LA's paradox. All right. So now here, a person visited a doctor, right? So for that person, two pills were offered. First one was blue pill, right? And the second one was red pill. So according to that blue pill, so the doctor said there is 100% probability, right? 100% probability you will live 12 years. In the second case, so doctor said there is 10% probability or 89% probability you will live 12 years, and there is 10% probability you will live 18 years, and there is 1% probability you will live, you will die. Okay? You will die. So this is the case. So when people were asked which treatment did they prefer? Blue one, right? Most of the people, they chose, I'm going to choose blue pill. All right? Blue pill, 100%, 12 years. Okay. Let's write it in the form of utility function. Okay? So now we are saying there is 100% probability of living of 12 years, utility of 12. Okay? If we write this prospect on this side, there is 89% probability of getting of utility of 12 plus 10% probability of utility of 18 years and plus 1% probability of utility of 0. Utility of 0 is equal to 0. It is 0. Okay, this is just simply 0. So we can simply just ignore it. It's 0. Okay? So now we have said it is greater than this one. If we are going to subtract from both sides, 0.89 utility of 12, all right, from both sides, then on the left side we are going to have, so 1 minus 0.89, it will give you 11% chance of living 12 years, right? I am subtracting from both sides. And on the left side, so now I'm getting greater than 10% probability of 18 years. Good? So now, according to this calculation, we see that people are preferring, right, higher probability of living 12 years than lower probability of living longer years. Okay?
In this case, there is no risk value, right?
So now, this is the case. So what is interesting here is those people, they were asked, there was second question, okay? Green pill and yellow pill. First, with the first one we are done. Second case, green pill and yellow pill. Yellow pill. So in the first treatment, they said, okay, there is 11% chance that you will live 12 years. There is 11% probability that you will live 12 years. And there is 89% probability you will die. So it's equal to 0. Utility of 0 is 0. Okay? And for yellow case, there is 10% probability, right? There is 10% chance that you will live 18 years. 18 years. So when those people were asked this question, most of the people, they said, I'm going to choose yellow. All right? Yellow. When question was asked this way, they were saying, I'm going to choose blue. But when the question was asked this way, they were choosing yellow. Is there anything wrong here? When they were asked question that way, they said, we are going to prefer 11 years of probability of living 12 years. But in this case, they are saying, no. We are going we prefer that 10% probability of living 18 years. So this is now contradicting each other. Okay, this is paradox. If you try to calculate expected utility, you will get that expected utility of red is greater than blue one. Okay? And here, expected utility of yellow is greater than green. This is no problem. So behavioral economists, higher the expected utility you will get, so this should be your choice, no problem. But the problem is here. Why people are choosing B instead of blue pill instead of red pill? Because of that 1% of deaths. So we will prove it today mathematically. Okay? Why they make such decisions. Okay? So students, now let me take your attendance. after taking your attendance. I will give you 5 minutes break, then we will continue. All right? So after this one, we will be doing those LA's paradox calculations. So, okay. So students, now we are going to start solving our second exercise, which is related to LA's paradox, okay? So now we have given those 4 prospects, okay, 4 prospects. So prospect A, B, C, and D. So let me write down all those prospects first, so we will need it. So now we are saying that in the case of A, in prospect A, so let me write it from the lowest to the highest, okay? In the case of prospect, from the lowest to the highest. What's the probability of having the payoff of $0? 1, right? There is 1% probability that my final wealth is going to be equal to $0. Second one. There is 66% probability that my payoff is going to be $10,000. There is 66% probability that the payoff is going to be $10,000. And 33% probability that there is 33% probability, the payoff is going to be 10,400. Okay? So now, in the case of prospect A. So now we have another prospect, which is prospect B. All right, prospect B. Now, $10,000 for sure. For sure, which means that 100% probability. There is 100% probability your payoff is going to be $10,000. Okay? So look, people were asked, group of people were asked. So now there are 2 options. So in option A, you can get the probability of getting 10,400 is 33%. There is 66% probability of getting $10,000, and there is only 1% probability of losing or getting nothing. And this is option A. In the case of option B, you can get $10,000 for 100%. So when people were asked this question, most of them, they chose B. Okay? They chose B. Good. So, and those people were asked second question. Okay? So now we have prospect C. In prospect C, there is 67% probability. Okay? There is 67% probability of no payoff, $0. Okay? And there is 33% probability. There is 33% probability of $10,400. All right, this is prospect C. In the case of prospect D, so if you are going to count, so here there is 66% probability of 0 payoff, and there is 34% probability of 10,000. So those people who chose B, okay, those people who chose B, they were asked, which one are you going to choose, C or D? So most of the people, they chose C, okay? Most of the people, they chose C. So now I'm not going to erase this part because we will need it for many times, all right? So look, if we are going to calculate expected utility, you know how to calculate expected utility now, right? So now we have to multiply 1% to 0 plus 66% to 10,000 plus 33% multiply to 10,400. So if you calculate this one, you will get that expected utility for prospect A, is going to be equal to 10,032. You can do it. You can do those calculations, okay? So in the case of prospect B, so it is 10,000, right? So the 1 times 10, so it's 10,000. In the case of prospect C, if you are going to calculate that expected utility of prospect C is going to be equal to 33% times 10,400, it will give you the number of 3,432. 3,432. Okay, you can calculate by yourself. And in the case of prospect D, if you calculate this one, it will give you 3,400. All right. People are choosing C over D, which makes sense. Okay? But now here, people are choosing B over A. Even though, in this case, the prospect is, it's 32, sorry. This is 32, okay? 10,032. Even though expected utility is higher, people are choosing B.
Is it 34,000?
Yeah.
3,400, sorry. 3,400. This is 3,400, not 34,000, 3,400. Okay? So now, this is the case. In this case, it makes sense, but in this case, it's now a puzzling question. So why are they choosing this one? Because in prospect A, there is 1% of loss. Okay, 1% of loss. Because of that one, people choosing B. So now, express probability of prospects in utility functions and compare. So now, we express in all those prospects, 4 prospects, and these are the utilities, okay? Expected utilities. Now we have these numbers, all we have found. Next, I have told you, students, because, for example, if I am going to choose prospect A, there are these 3 outcomes, right? If I end up with having 10,400, I'm happy? Yes, right? If I end up with 66% of 10,000, still okay. If I end up with this one, I will be unhappy, right? Disappointment. So here, this is disappointment. This one is normal case. This one is elation, happiness. All right? So now we are going this expected utility function, which is controlled for disappointment, which I showed you. Now, listen very carefully, okay? This is really confusing if you don't understand. It's very easy, but it's very confusing. So what you need, if you understand, if you have it in the exam, what you need only calculators. This is it. The answer will be ready for you. All right. So let me write down that expected utility function for disappointment, okay? So where should I write? Okay, let me write it here. So our expected utility, I am saying that sum of probabilities, okay, now we have different probabilities. And now we have that payoff, okay, from different utilities from different payoffs, okay, different payoffs, plus we have disappointment. It can be either disappointment or elation, all right? It will represent both. So now we have here of payoff, okay, payoff of and minus prior. Good. So now, what you have to understand is this one, all right? Or I can write it like this. So because to make it simple, I can just divide this one into 2, right? I can write it like this. Sum of probabilities of utility of payoffs of different, utility of different payoffs. Can I write it like this? Plus sum of probability, because this probability is related to both, okay? Probability of our d u xi minus prior. Okay? Now I can write it like this. So I will need it. So look. So what does it represent? You should understand this one. All right? What does it represent? So look. Now, our disappointment, okay, disappointment function is going to be equal to theta times g squared if this G is greater than 0. I will explain you what is this now. If this G is less than 0, then we will use this one. We will use this one. So, just a second. Let me write it like this. So now I can write it. I can write this formula. I can write this formula as this one. So my sum of probability of I, utility from the payoff plus, now this is sum probability of I times plus minus theta G square. Theta G square. Because this G can be minus or plus. I will explain. So this one is equal to this one. When it is going to take the sign of negative and when it is going to take the sign of positive. You should understand this one. This is it. So look, let's suppose I am expecting 10 sums. Okay? I am expecting $10. And I ended up with getting 0. Is it higher than my expectation or less than my expectation? Minus 10, right? It is less than my expectation. So this is now G. If it's going to be less than my expectation, then you will use theta minus theta G square. Okay? You know this is negative. So here it's y squared, so minus theta minus 10 square. Don't think that this minus it will go inside. No. Okay, now it's here. Minus 10. And now there is the second case. I was expecting 10, but I ended up with $12. So now how much it is different? $2. Is it positive or negative? Positive. So in this case, you will use plus theta, our G square, where plus theta, our G is equal to now? 2 square. This is it. Okay? This is it. So here, look, if I end up with 0, my expected value, how much I was expecting? 10,032. How much is it less? This much less. So theta will be minus 10,032. If I end up with 10,000, is it less than my expectation? Yes. So theta will be equal to, G will be equal to 32. Okay? In this case, it is now greater. Okay? So this is what you have to know. This is it. This is it. So now let's do those calculations. Then we will add them all. We will add them all. All right. So now in the next slide, look. Now we are considering two cases. When theta is 0 and when theta is 0.0002, which means that people give some weight on disappointment. What if theta is 0? What does it mean? What is theta here? Okay? If theta is 0, is this type of people. For example, if you lose your money, if you end up with 0, you were expecting 10,000, but you got 0. You got 0. And people like this, oh, it's the will of God, no problem. All right? That type of people. It's the will of God, no problem. They don't get disappointed. If they get more also, yeah, it's the will of God, and now it's a blessing from the God, so I'm very happy. This is it. That type of people, their theta is 0. Okay? Theta is 0. So look, now in here, now let me calculate. Look, this here G is going to be different. G is going to be J, okay? In different case it will be different. So now, because this theta is same for in any case, I can write this equation as sum of probability of I, payoff of utility of the payoffs plus theta, because it's same in any case, times sum of probability of I plus minus Gj square. Because this G will be different. In this case it's different, in this case it's different, in this case it's indifferent. All right? So look, I'm saying if theta is equal to 0, then our function will be just expected utility function. If it's 0, okay, if it's 0, then people do not pay attention to disappointment or elation. No problem. So it will be equal to this one. First thing we are asked, if theta is 0, find expected utility. We have already found. We have already found. Theta is 0, because if theta is 0, now this is what we have done already. Okay? So now our utility function of any prospect, which is sum of probabilities times that payoff, utility from any payoff, which is equal to this one.
But they are the values, not the probability.
I said it's utility. It's not value. Utility function, okay? So now it will be equal to this one. I think here you have no problem in calculating, right? So now we are not going to spend on this part, but now if we consider 10,000 people or 100,000 people, you can find 1 or 2 who do not care about the loss. Most of the people in daily life, they really care about the loss, which means that they put some weight. So now, if theta is going to be greater than 0, then it will change, okay, the outcomes. So now we will calculate. All right. Let's start calculating.
Theta will be given in general, right?
Theta will be given to you. If it's in the final exam, it will be given to you. You will not be, guessing it or developing.
You should just only calculate the G, right?
Yes, you should find G and you calculate. All right, let's do it. Let's calculate. In the case of prospect A, what's going to be the case? What's going to be the case? All right, I am going to calculate expected utility, which is controlled for disappointment. So now, prospect A, first one, we should calculate expected utility. Everything is given for us, yes? So now, there is 1% probability of getting 0 plus 66% probability of 10,000 and 33% probability of 10,400 plus, because now we have this part, yes? This part. This part is important. All right? So now I am saying here, probability, theta, and the others. So look, in this case now, let me write here, so each one plus, if I end up with this 1% probability, it will be 0. How much is it going to be larger or smaller than my expectation? 32, right? 10,032. Is it negative or positive? Negative. Minus 10,032 square times theta, 0.0002. This is the first one. And don't get it confused. So this square is for this one only. Okay, this minus is not.
It's better to have you have to put minus also.
So here, okay, minus. It will be minus, okay? Anyway, minus, okay? So next one, plus 66% probability, 0.66% probability that I will get 10,000, and it is how much less than expected utility? 32. So here, minus 32 square times 0.0002 plus. If now there is 33% chance, I'm going to end up with 10,400. How much is it different from my expected utility? So now it is positive. 368 square times 0.0002. equal. Now we have to calculate this one. All right? So for calculating this one, you need calculators. All right? Calculators. What you need, just write these numbers and just put everything in the calculator and get the results. So if you calculate this one, you will get the number of 9,839. 9,839.52. This is the result when we control for disappointment, okay? So we calculated for prospect A. Let's do it for prospect B. Utility.
Can we compare this one with the initial utility?
With this one? No. We cannot. We cannot because here theta is 0. Okay? Here, what we are comparing to this one? Expectation, okay? We are expectation for this one. So look, utility for prospect B equal. So now we are saying there is 100% probability of 10,000. Is there any probability which is going to be less or higher than 10,000? That disappointment is not applied here because it's 100% this one. It's equal to 10,000. Okay? 10,000. So now you can compare A and B. In which one expected utility is larger? In the case of B. This is the reason why people were choosing B. Okay? This is the reason why people were choosing B. Because in here, there are two, those negative outcomes. Disappointment, and here elation. Disappointment level is greater than elation. Okay, good. We are done with this one. Let's calculate it with C and D. How is it going to be different? Because here we have 0 cases, right? 0 cases. Let's do it for C. Let's do it for C. So utility function for C equal. Now we are saying there is 67 probability of getting 0 plus there is 33% probability of 10,400 plus. Now plus there is 67% probability of 0. Our expected utility is 3,432. So it is, which is negative, right? Negative 3,432 squared times theta 0.0002 plus. Second case. Now I'm ending up with 10,400. 10,400. So now this is 33%. So is it greater than my expectation or lower? Is it positive or negative? My expectation is this much. If we are going to subtract these two, I think it's going to be, just a second, 6,968, right? Square times 0.0002 equal. If you calculate this one, you will get the number of 4,836. 4,836.2. Okay, if you calculate this one, you will get this number. 68. Did I say 68? 36. Okay, 36. Sorry. Yeah, 36. 36. So this is going to be the result. And if you calculate it for prospect D, okay, equal. In the case of prospect D, there is 66% probability of getting 0 plus 34% probability of getting 10,000 plus. And now we will control for disappointment, where we are saying the disappointment of there is 66% probability of getting 0, which is less negative, so 3,400 square times 0.0002 plus, and now 10,000, which is much greater, right? Which is 34% times, which is plus here, 6,600 square times 0.0002. If you calculate this one, then it will give you the outcome of, oh, sorry, students. Here, I made small mistake. Here, if you do calculations, it is not. I can confuse it. 50, 100, 58. 50, right. It's in the case of C, okay? This one. But in the case of D, it is 4,836.2, okay? So when people were asked, they were choosing B instead of A, even though expected utility were higher. So why? Because it has some elation and disappointment. So now it makes sense, right? And people were, in the case of C and D, they were choosing C. Does it make sense? Yes, okay? So now this is the case, C. Done. So this is how we have to calculate this one, all right? How we calculate this one. So in the book, students, in the book, these calculations are not given. What is given, just table is given, okay? Table is given and numbers are given. So here, this is expected utility is equal to what? 9,839. Okay, here is 10,000. Here is 5,158. And here it is equal to 4,836. Okay? If 0, look students, if you are in the book, if you would like to know where do these numbers come from, if 0, this one, it represents this one. If 0 represents this. If 10,000 represents this, okay? If 10,400, it represents this. Net disappointment, it means it represents this all. With all probabilities, okay?
What about the calculation, the last one?
Huh? 9,800, then it will be this expected utility, this one, plus this net. It will give you this number. Okay, so when you're reading book, if it's a bit confusion, then you have to remember this one. So students, I think now it's clear. It's clear. So if you have it in the exam, just what we have to remember, this one, and just calculator. So therefore, you should have very nice calculator. Because the second part of this, now we are going to find it with weighted probabilities, which is much more complex than this one. I'm erasing it. Okay. So now let me just leave these expected values. I think, okay, let me keep it here. Okay, so now expected rank dependent expected utility. Rank dependent expected utility. Now this is utility function, but here this probability is weighted differently. Okay, weighted differently. So people who are really risk averse, even though there is 1% risk, they see that risk as something very large. All right? There was, for example, in March 2020, even though the probability of getting infected by COVID was this much, very small, but people were seeing it, if I just go outside, immediately I will get COVID. The probability is 90%. Okay? People were thinking emotionally. So here, this weighting is represented, even though this probability is very small, but people may weight it large. Or they may underweight it or overweight. That's the case. So now we will try to explain it this way. Okay. Try to understand this one, okay? So now our weighted, that rank-dependent expected utility function is given as, so the sum of that weighted probabilities, this is weighted probabilities, overweighted or underweighted, and that payoffs, utility from the payoffs. Good. We are given this one. And now, what is this weighting equal to? Okay, this is what is going to confuse a person, which you have to understand. It's not difficult. It's not difficult, but you should understand. So look, we are saying that in order to find that weighted probabilities, then we have to, first, number one, we have to rank probabilities from the worst outcome to the best outcome. What is the worst outcome in prospect A? 0, right? Second worst is 10,000. The best one is this one. So now we have to rank first worst probability, second worst probability, third worst probability. So here there is no worst probability. Okay, 1. Here, worst probability, best probability. Worst probability, best probability. So you don't have to get, so you should make it like this. Okay, good. So now here we have this pi, and now this pi probability of I is worst one. Okay, worst one. Plus second worst one. Plus, and so on, best one. And you have to subtract from pi, okay, pi, second worst one. You will drop the first one, okay, second worst one, which is pi, because then it will consider how it is weighted, okay? So now I plus 1 plus and so on plus probability of n. So now this is it. Now this is it, all right? So let's suppose here, let's suppose now, once I found these probabilities, it was equal to, let's say, z, okay? It became equal to z. And this is, it became equal to, for example, g. It became g. It became g, all right? After finding out this one, then we can apply weighted probabilities formula here. Now this is probability. Now this is equal to, so we will apply it with numbers, no problem. So now this is equal to, first one is equal to z in the power of gamma, all right, over z in the power of gamma plus 1 minus z in the power of gamma, all of this in the power of 1 over gamma, minus g in the power of gamma over g in the power of gamma plus 1 minus g in the power of gamma, 1 over gamma. It will give you first probability, weighted probability. First one.
Why we are weighting only the first one?
I'm saying it's first one. Then we will consider second one. Then third one. Okay? So now we did it. So if you understood this one, now let's calculate ourselves, okay? We will find. Look. In the case of, now we are considering gamma is equal to 1. What if our weighting, that weighting is equal to 1? If gamma, students, if gamma is equal to 1, it's that type of people who do not weight, overweight or underweight. So if they lose, it's the will of God. If they get more, I got blessing. This is it. So, yes, if gamma is equal to 1. If gamma is less than 1, between 0 and 1, then weighting will be different. How? How is it possible? For example, so now we are going to, let's consider our utility function is for risk neutral, okay? Our utility function for risk neutral, which is x, okay? If gamma prospect A is preferred to B, if gamma is 1, if people don't care about those losses or whatever. So now let's calculate it in the case of gamma is equal to 1. Look, I will show you because it will not change anything. So look, all right, our gamma is equal to 1. Gamma is equal to 1. And I'm going to apply it. In order to apply it, I have to find probabilities first, right? So now I have to find weighting of 1, the worst outcome. My pi is equal to worst outcome, probability 0.01 plus second one, 0.66 plus third one, 0.33. Okay? 1, 2, 3. Worst, second worst, best. Okay? Minus second worst, 0.66 plus 0.33. This is equal to pi, probability of 1, right? Minus pi, probability of 99. Okay. So now I'm going to calculate this one, students. 1 in the power of gamma is equal to 1 over 1 in the power of 1 plus 1 minus 1 in the power of 1, 1 over 1 in the power, minus 0.99 in the power of 1 over 0.99 in the power of 1 plus 1 minus 0.99 in the power of 1, and this one is in the power of 1 over 1. Equal. What is it equal to? If gamma is 1, so now it will be 0, 1. So here, this and this, it will be cancelled out. It will 1. So 1 minus 0.99, yes? Which is equal to, again, to 0.01. There is no weighting. All right? So if the probability is 0.1, it will be the same. If you apply for the second one, W2, again, it will give you exactly the same thing. It will not change. 1, 1, it will, any probability will not change if it's 1, gamma if it's 1, okay? So now here, weighting 1 is equal to 0.01, 0 case. This one is 10,000 case, 66%. This one is 33%. Expected utility will be equal to 10,000, 32. Okay, because this weight will be equal to probability I if gamma is equal to 1. If gamma is equal, if it's not equal to 1, then this weighting will be different. Okay? So now we are considering gamma is equal to 0.61.
Why maybe those last two fractions we could get the result from the period itself?
From here? So I just showed you how we calculate. So now let me show you with 0.61. Okay, 0.61. So in the final exam, I will not give you to do it, just get a result. You have to write it. I should know that you understand.
Is the same in all the way around? Is the result will be the same?
All the results will be the same? What do you mean by saying results will be the same?
When using these fractions or not?
I mean, he means like the second part is needed also, like to
Yes,
calculate. The first one is like it's showing already the answer.
You mean second part is needed?
Yeah.
It is needed.
Why? You can find the first.
Yes, you can find it with calculator. But you are not a calculator. All right? So therefore, if you don't have it, let's say you have this, but you have not, then you will get only partial credit, minimum.
Is the result will be the different if the, what was that, y will be different?
If gamma is different, yeah, it will be different. Let's see. Gamma will be, okay, now we are going to consider the case of gamma is different. So look, if gamma is 1, it's same. Everything is same. But now gamma is now 0.61, okay? We will be finding weighting of 1. Let's find it. Now we are saying that in order to find our weighting 1 for prospect A, okay, this is for prospect A, students, for prospect A. So now our pi is same like this. So worst outcome is 1%. Second worst is 66%. Best one is 0.33%. Minus. Second worst is 0.66 plus 0.33. I think you got this one, right? And this is equal to 0, oh, sorry. Our pi, where is my? Our pi 1 minus pi 0.99 equal. And now here we will write, okay, 1 in the power of 0.61 over 1 in the power of 0.61 plus 1 minus 1 in the power of 0.61. Everything is in the power of 1 over 0.61. Okay? 1 over 0.61 minus 0.99 in the power of 0.61 over 0.99 in the power of 0.61 plus 1 minus 0.99 in the power of 0.61 in the power of 1 over 0.61. Here you need calculator. Okay? So here you will need your calculator. So therefore, don't use that Soviet type of calculators which has no power function. Okay? You should have those power functions. All right, so now if you are going to calculate this one, it will give you, just a second, what was it equal to? Oh, just a second, I had those numbers calculated. Okay, here. It will be equal to 0.088. What does it mean? Even though the probability of getting 0 is 1%, people see it as 8%. All right? People see it as 8%. Done. We found W1. Now we have to find W2. W2. In order to find W2, now again, W2 is equal to, look, here, we will start from this part, okay? W1 will be considered from here. W2 will be considered from here. W3 will be considered from here. So we will consider this one. So here, 0.66 plus 0.33 minus pi 0.33. All right? So now it's equal to pi 0.99 minus pi 0.33 equal. And now we have to calculate it. 0.99 in the power of 0.61. 0.99 in the power of 0.61 plus 1 minus 0.99 in the power of 0.61. This all in the power of 1 over 0.61 minus 0.33 in the power of 0.61 over 0.33 in the power of 0.61 plus 1 minus 0.33 in the power of 0.61 and everything in the power of 1 over 0.61. Okay? If you calculate this one, it will give you the probability of 0.57. 0.577. So now, people are underweighting, getting 10,000. Not overweighting. Okay, here is underweighting. And then let's find the last one. The last one is the easiest one. Because W3 is equal to pi only 1. Last one. 0.33. Okay? Good. Less probabilities and differences you have, the easier will be the calculations. If I give you 4, one exercise will be enough for 3 hours.
Yeah.
But giving 1, it's impossible. Okay? So this is the key. So now let's find it. So this will be equal to 0.33 in the power of 0.61 over 0.33 in the power of 0.61 plus 1 minus 0.33 in the power of 0.61, and everything in the power 1 over 0.61. So if you calculate this one, this is equal to 0.33. Equally weighting. Okay? What is here is, you can see that what here is, they are underweighting. This one is equally weighting, but here they are overweighting, loss, 1%. Okay? And now, once we found it, after this one we will find, we can apply this formula.
I don't understand what the overrating here. The first one, going to
The probability of getting 0 was how much? 1%, right? But now people are seeing it as 8%. Okay? As 8%. So now we have found finally, found it finally. And students, the rest is very easy. What is difficult, finding those weights. Okay? So now, in order to find that expected rank dependent with the rank dependent expected utility for prospect A, so what is weighting of 1? 0.088 times 0 plus 0.57, okay, times 10,000 plus 0.33 times 10,400. If you calculate this one, it will give you the number of 9,249. 9,249.5. Okay, it will give you this number. So we are done with first one. This probability is equal to 0.88. This one is 0.57. This one is 0.33. And now utility is equal to 9,249. All right? In the second one is same. It will be 10,000 again. Why? Probability is 1. So here, if it's going to be 1, in any case, it will be equal to 1. Very easy. It will be again 10,000. Okay? So now, prospect B, if you are going to find that prospect B, it will be equal to 10,000. Which is greater? B. This is the reason why people are choosing B. Okay? So now, in the case of C and D, this is going to be your homework. All right? It's no problem. You can easily calculate it. Why? 0.6. I can show you, okay? Let me show here. So, for example, if you would like to find W1, look, probability, it's easier than this one. So, worst one is pi 0.67, right? Plus 0.33 minus pi 0.33. And now we have pi is equal to 1 plus pi 0.33. Exactly like this one, you will put powers of 0.61 and calculate.
Easy, right?
Right.
from the worst case.
Yes, this is the most important thing. From the worst case to the best case. If you make it opposite, then your answers are wrong.
I have a question here. Why you didn't calculate the W2 and W3 when the Y was equal to 1?
The answers will be same. Because it's 1. Okay. Let me show you why I did not calculate. Can I erase this part? I can erase this part too, right? Okay, let me show you that one, why I did not calculate. You mean in this case, right? Okay, good. So look, I did it for W1, let me do it for W2. It will be same. W2 equal pi, second worst, right? 0.66 plus 0.33, is it the case? Minus, this one is going to be 0.33, right? I think you know. Second worst, best one, and the last one. This is now pi I plus 1, this is pi n, last one. So as we did this one, okay? So now this is equal to, because gamma is 1, now it's equal to 0.99 yet? Is it? So now 0.99 in the power of 1 over 0.99 in the power of 1 plus 1 minus 0.99 in the power of 1 in the power of 1 over 1 minus 0.33 in the power of 1, 0.33 in the power of 1 plus 1 minus 0.33 in the power of 1 in the power of 1 over 1. So what will happen then? Now, these two guys will be cancelled out, right? These ones will be cancelled out. So now this is equal to 0.99 minus 0.33, which is equal to 0.66. Same. Probability will not change. It will be same. Okay? Same. If you do it for this one, it will be also same. Because gamma is equal to 1.
I have a question. So, in the prospect A, we had 3 probabilities, yes?
Yes.
But when it comes to 2 probabilities, how can we find the third one? In the C,
All right. So look. Okay, good question. So now, this W1 means if 0. W2 means if 10,000. W3 if 10,400. For example, oh, where was it? Okay, in prospect D, in prospect C, we have 0 case and 10,400. There is no W2. Only 2, okay? So then you can consider it as W1, this is W2. All right?
the worst one and the best one.
Yes, worst and the best. So students, now we have last slide, this one. Next week I will explain. This is prospect theory. So again, calculations. So thank you for coming. You can go.